All right, so this is a picture that we are going to be dealing with on every one of these problems. Now, that picture might kind of double itself up, as we see in a couple questions today and tomorrow, but the most basic version of the questions that we see are going to deal with that picture, okay? We're going to be trying to deal with something that we're looking at the top of or the bottom of, and we're going to have these horizontal lines that we have to use in conjunction with what we call a line of sight, okay? So your line of sight is the idea that from your eyeballs to whatever you're looking at, there's an imaginary line that connects those 2 points, okay? That's your line of sight. If you're looking up at something, your eyes have to move from the horizontal, they have to elevate. Does that make sense? Okay? So your angle of elevation is looking up at something, okay? So that's that angle down there at the bottom left. If I'm looking down at something, so now I change the rules and I'm standing on top of the building and I'm looking down at the car, your angle of elevation, your angle of depression has to be between an implanted horizontal line. So we put that additional horizontal line in there because the idea is if I'm standing on that building, I'm just looking straight out, okay, that is my line of sight straight out, correct? If I look down then to the car, what is the angle that from straight out to down, what's that rotation that my eyes had to make to see the car? Does that make sense? That angle is called your angle of depression. Does that make sense to everybody? Okay. As that object gets closer to me, think about this. And I don't know if I can, these are all like individual things. Hold on a second. As I move that car closer, what happens to that angle of depression? It gets larger, okay? The closer the object is to my position, or the closer I am to the object, the greater the angles of depression and angles of elevation get. Does that make sense? Okay? So essentially, if this car was right here, and you're standing on top of the building, or you're in the car looking at the top of the building, wouldn't you have to look straight up? And that would be a 90-degree angle of elevation or depression, okay, which we would not then use SOHCAHTOA to figure this stuff out if that was the case. What do you notice about the horizontals are what kind of lines to one another? What's the relationship between them? Parallel. So the angle of depression and angle of elevation are what to one another? Equal. Why? They're alternate interior angles, okay? So when transversal intersects two parallel lines, alternate interior angles are congruent. Jenna? Yes. And something we have to kind of infer is that the ground, for the most part, is flat, horizontal, in a lot of the things that we're interested in doing here, okay? Looking at so this was like question number 1 on that quiz, okay, some type of scenario like this. If I'm the bird and I'm looking at the guy in the hot air balloon, the dotted line represents the bird looking straight out so that their line of sight is parallel to the horizon, okay, or parallel to the ground. If that bird then looks at the guy in the hot air balloon, his eyes had to go down, right? So angle 1 is an angle of what? Depression. If you're the guy in the hot air balloon and you're looking at the bird, angle 2 is what? Angle of elevation. What do you know about angle 1 and angle 2, though? They're congruent. They're alternate interior. What about angle 3? What would you call that if I'm the guy looking at the bottom of the mountain? Angle of depression. And angle 4 would be angle of elevation. Okay? Huh? Elevate means go up. Depress means, like if you depress something, you push it down, right? Does that make sense? Okay. So depression means going down, okay? And elevation means going up. All right, so what's going to happen, guys, is that they're going to give us a story problem. And there's not going to be a picture attached to it probably 70% of the time. when that happens, we're going to have to take the information out of the story. We have to read, comprehend, know some vocabulary that allows us to conjure up a picture, okay, and implant values into that picture that we can then recognize whether we can use special right triangles, maybe we can use Pythagorean theorem or SOHCAHTOA in resolving unknown distances, okay? This is a huge aspect of indirect measurement where we're using values that we know or that we can readily attain to find values that we don't know, okay, without having to measure those values that we don't know, or those lengths that we don't know. So, here's the idea, and this is kind of I think the more examples we can see, the better we get at this, okay? I'm not saying that there's a one and only way of approaching these types of questions, but I like to go line by line. I don't even read the whole problem usually, okay? I am going to suggest you do that, but I go line by line and piecing things together until I get to the last line, and then hopefully I've got a picture when I'm done, okay? With you guys, let's go ahead and read the whole thing first and then go back and go line by line. So it says, an observer on the first floor of an airport control tower sights an airplane at an angle of elevation of 32 degrees. The pilot reports the plane's altitude is 3.5 kilometers. What is the plane's horizontal ground distance from the tower? Okay? All right, so let's go back to the first line. An observer on the first floor of an airport control tower sights an airplane at an angle of elevation of 32 degrees. That should tell you right away that you have a control tower, and somebody's in that control tower, and they're looking at a what? They're looking at an airplane. Where is the airplane going to be if there's an angle of elevation? In the air. It's going to be in the air. Okay? So my angle of elevation is created from my line of sight, okay, and my horizontal. Well, the blue line is my horizontal, right? Okay? The angle of elevation that's created by those two things is 32 degrees. I'm going to put 32 degrees in right there.
What is the little, oh wait, that little square?
Yeah. So when we draw these guys, you don't have to be good at art. You don't even want to put pictures in, that's fine. Just put letters in. So C for control tower, P for plane, that kind of thing. I like to put in little graphics because I think it makes the picture a little bit more concrete and make sure that I've got things correct when I got the picture back or I create it completely. I can go back to the words and see, does my picture really mimic what they were saying? Okay? Or if I just have letters like C and P and that kind of stuff, I'm not sure that I get that. All right, it says the pilot reports that the plane's altitude is 3.5 kilometers. What's the plane's altitude? What does that mean? Okay, so how do I determine that? What do you mean by how high a plane is? Off the ground. So how do you measure that? Say again?
She said sea level. I was going to say like it'd be your vertical.
Okay, so you're both right. So our altitude is always based off of sea level, but when I go there, what should that line be compared to my horizontal? It should be a right angle, okay? So when we see that word altitude, we're talking about if we were to freeze physics and that plane were to fall straight down, how far would it have to fall straight down? Okay? So in this case, that'd be 3.5 kilometers, right? Does that make sense to everybody?
Yes.
Okay. Now the next part of this is the actual question that's being asked. It says, what is the plane's horizontal ground distance from the tower? There are two values that you don't know in this picture. You do not know, let's just call this L, and let's call this X. You don't know L and X, right? Which one of those do you think is the horizontal ground distance? It'd be X, right? Okay. L, does anybody know what they would call L? They would just call L the distance from the control tower to the plane. Does that make sense? When they say horizontal ground distance, the idea is if I were to put a car at the control tower and tell them how far they need to drive to where they're directly underneath the airplane, I would tell them X. Does that make sense? Okay. Now, once I've got this picture, I'm going to, you know I don't have to do this, but I'm going to erase some things. Does that look like question 1, 2, 3, 4, 5, 6 from the worksheet I gave you? Okay, so every one of these questions that we do should eventually look like one of those questions off the worksheet that we've been working on the last couple of days. Shayla.
Could you, like, why do you have to erase the L?
You don't, but because I'm not looking for it. I don't want that distance. I'm not interested in that distance in this question. I'm only interested in the horizontal ground distance. So which trig ratio would you use here if I want to focus on that angle, and I have this side and that side? I will use tangent. So I say tangent of 32 is equal to opposite, so 3.5 over x. Cross multiply and divide will eventually give me x is equal to 3.5 divided by tangent of 32. And we should be able to evaluate that with our calculator. Make sure you're in the right mode. So 3.5 divided by tangent 32, 5.6. Okay, so 5. Obviously, pay attention in your homework tonight to what they ask you in regards to rounding to certain decimal places, that kind of thing. But 5.6, now I want to make sure that I have the right units. So what was the altitude in? Kilometers. So then I want this in kilometers as well. And that's something to be paying attention to with some of these questions is they will give you different values throughout and ask you to be able to work with converting kilometers to meters, meters to centimeters, feet to miles. Those are things we have to pay attention to. Is that all right? Okay. Let's do another one. All right, so my hopes are that you guys read the email and maybe printed off some of these so that you came to class, you don't have to write all these statements out. My suggestion, if you did not do that, don't write that entire thing out, okay? I would write down 8.4 PowerPoint, slide 9. We're going to do the work, and then later you can go back and reference slide 9 when you need to. Does that make sense? The 8.4 PowerPoint will always be online, will always be in your email, whatever. You don't need to rewrite down all that stuff because it's going to be time-consuming. And I want to get into seeing as many of these as we can today. So it says a helicopter pilot sights a life raft. The angle of depression is 26 degrees. Helicopter's altitude is 3 kilometers. What's the helicopter's ground distance from the raft? All right. So situation, helicopter, life raft. Where's the helicopter at? In the air. Life raft would be on the ground. Okay, probably in the water though, right? And that's, I mean, water and ground. We're gonna say they're synonymous here. They're flat surfaces. Okay. So there's my life raft. Okay, we've got our helicopter. Helicopter. What? You don't think that looks good? All right. So the line of sight to my life raft would be that distance right there, correct? What is that line right there called? Horizontal. Okay. Now I need that, and this is the case this makes these questions different than angle of elevation questions. When they talk about an angle of depression, you always, from the observer, have to add in or include an additional horizontal. Okay. So I'm just taking this line here and coming up with one that is parallel that goes through the observer. The reason I had to do that, think about the pilot. The pilot's flying the helicopter, they're looking straight out, right? Okay? If they're flying this helicopter, they're looking straight out, their line of sight, their normal eye position is following that horizontal, right? When they want to look at the life raft, their eyes have to go down, correct? Their head needs to tilt. The amount that their head tilts, that rotation, is the angle of depression. So this here, That there is the 26 degrees. Okay. Helicopter's altitude. Same as the airplane's altitude in the last question, right? So helicopter's altitude as a physical distance is the same, though, isn't it? Yes. Okay, so it's that distance. It's how far it is off the surface. That's 3 kilometers. Okay. Now, my hopes are you see if you have a right triangle here, correct? Okay. Now, this 26 right now is not part of this right triangle here, correct? But what can I do with that 26? Put it right there. Okay? Because it's an angle of depression from when the pilot is looking at the raft, right? But if the raft is looking at the pilot, for them to make eye contact, they both have to be using the same angle, right? One has to be using angle of depression, one has to be using angle of elevation, and they have to be congruent. Those are alternate interior angles. So once we have that, is that a pretty straightforward right triangle to allow us to find that distance right there? I'll call that x. Which trig ratio are you going to use? Tangent. Tangent of 26 is equal to 3 over x. X equals 3 divided by tangent of 26. I'll let you evaluate that, figure out what that is as a decimal. Last class said, why do we keep using tangent? A lot of these, and then we'll see some that we use sine and cosine, but predominantly a lot of them are tangent because think about a helicopter. Doesn't it have the instruments to provide us that number for an altitude pretty easily? Okay. A lot of things that we do, the vertical distances or the horizontal distances are going to be readily accessible. They're going to be things that we can find easily, where finding the hypotenuse, which is ultimately your line of sight, finding that is hard a lot of times. Okay. There are situations like if I'm flying a kite, okay, then the line of sight is ultimately the string of that kite. That would be a situation where I could figure out the length of the hypotenuse. Does that make sense? Okay. But otherwise, a lot of these questions, that line of sight is not a distance that we can find physically by measuring it directly. Okay. We can use indirect measurement to find it, but having that as a known value before we start the problem is pretty rare. Okay. When you see these types of questions, so airplane questions, helicopter questions, those types of things are common. Another type of scenario that's common is shadow questions. Okay, and it's the way that the sun interacts physically with an object to cast a shadow allows us to find the height of an object pretty easily. Okay, so I've got a monument. It says monument casts a shadow 215 feet long when the angle of elevation to the sun is 52 degrees. Find the height of the monument. Okay, so if I got a monument here, okay, and it casts a shadow that's 215 feet. So I'm going to say that, do it in blue here, that shadow right there is 215. Okay, so where would that put the sun? In the sky, but where? To the monument, to the left of it, right? Okay. When it says the angle of elevation of the sun is 52, what that means to us, if you were to lay on your stomach, right there, and you were to put your eyes at the tip of the shadow of the monument, okay, and you look directly at the top of the monument, because the monument, the top of that monument, that whole thing is casting that shadow, right? If you continued your line of sight through the tip of that shadow, you're going to be looking right in to the center of the sun. And you don't want to look in the center of the sun, do you?
Except it's a solar eclipse.
Okay. You still don't want to do that. All right. So the assumption is that our monument's perpendicular to the ground, right? Okay. The angle of elevation then would be this angle here, line of sight into the center of the sun through the tip of the object. So sometimes this is a monument, sometimes it's like a basketball pole, sometimes it's a tree. The scenario changes, but it's the same idea. Does that make sense? Okay. I said that's 52 degrees. And this is what I was talking about. This is the reason why tangent is used a lot of times in contrast to the other ratios. If you had to do this, if you were interested in using this concept to measure the height of something, would you be able to find that distance pretty easily? Does that make sense? You'd be able to walk that, you'd be able to measure that shadow with a tape measure, pace it off or whatever. You would find it very, very, very difficult. My tablet keeps dying. Give me a second. You would find it very, 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 very difficult to find that length with a tape measure. Does that make sense? Okay. But now if I wipe away all the context of the problem, do I have a right triangle in which I'm trying to find that length right there? Does that make sense to everybody? So which trig ratio would I use? Just tangent again. So tangent 52 is equal to opposite over adjacent. So 215 tangent 52 is equal to x. And again, I'll let you evaluate that. But a lot of your questions, you know, my thought is that the airplane question, the helicopter question, even the shadow question, they're all the same, okay? They all create that right triangle. Somehow they give you an angle, a distance, and ask you to find an unknown distance using SOHCAHTOA. Yeah? Here, I don't really care here in your notes. Go 2 decimal. If it never tells you, the safest thing is like 2 decimal places. The more, the better. So don't round to a whole number or anything like that. On your homework tonight, it'll tell you 10th place, whole number. When it tells you whole number, I think that's ridiculous because there's no need in being that kind of careless with rounding. But just pay attention to the rules on the worksheet. Okay, so this is another question. You guys know what guy wire is?
No.
All right, if you look at the spelling, a lot of people prefer, or they say it's a guide wire. Okay, that's a misnomer. It's G-U-Y. That's how you spell it. Okay, but you've seen these. Yes, you have, Deja. Telephone poles.
Those are guy wires?
No, those are telephone lines, power lines, cable lines, that kind of stuff. But these things are, there's a lot. Would you guys agree that these things are probably pretty heavy?
No.
They are. Okay. So those black wires are heavy. And if I just have this telephone pole here with all this counterweight over here on the right-hand side, isn't that telephone pole going to start leaning that way?
Yes.
Okay. So what do? They create a support out of braided steel. Okay, and some of you say, I got one of those in my yard. Yeah. Okay, and you go, they're not. There's no power going through those. But that blue line that is going to stabilize that telephone pole is called a guy wire. Have you ever been to? You guys know where Spectrum is, Time Warner?
Yeah, by Taco Bell.
Okay, so you look at those towers. They got a bunch of braided steel wires, cables coming off the top of those towers to the ground, right? Do you know why? To support it, because it gets really windy, right? And those things will start swaying, and when they sway, they start to get stress on them, and they break, right? But if we have those guy wires, it's going to keep them rigid, and they're not going to be able to sway. Okay, does that make sense? Yes. So in this question here, it says the length of a guy wire supporting a radio tower, so let's just say that that's my radio tower.
Oh my God.
Okay.
I was using 10. How do you rate that?
So the length of a guy wire supporting the radio tower is 175 feet. This is a situation where that distance, the hypotenuse of your right triangle, is actually something that we can measure. The people that constructed this, that put that up, probably recorded somewhere in their blueprints that dimension. Does that make sense? So it's readily accessible. It's something we can use. So the angle of elevation created by the guy wire and ground is 65 degrees. Okay? So would you guys agree that that's the ground?
Yeah.
The angle of elevation between the ground and the guy wire is 65 degrees. Okay? That is a very easy thing to attain. Okay? That angle measurement. Now, if you, obviously, the larger the instrument you have here, the better this would be. But if I took like a giant protractor, let's say this protractor is like the size of this, whatever this is. What is this? Shelf. Yeah. Let's take a protractor that big, and I set it right there. And the reason I want it to be big is so that it's accurate, right? Could I see? So I would keep the bottom of my protractor on the ground, and then that guy wire would go through an angle, right?
Yeah.
And I'd be able to record that, okay? Another way to do it is take a large piece of maybe cardboard. Could you take cardboard and place it right there, come with a pen or a Sharpie, and on that cardboard, so you're laying it up against that wire, can I draw that angle? Does that make sense? And then take that angle back to maybe a smaller protractor, and I can actually figure out that measurement. That's something you could do pretty easily, okay? Now I want to know the height of the tower, right? So which trig ratio would you use to find y here? Sine. You say sine of 65 is equal to opposite over hypotenuse.
I didn't like look at opposite. Like COH. No way.
Okay. Evaluate that, and you've got now the height of that tower. Okay. So I teach trig out at Rhodes every once in a while. I teach it here as well. But the lead instructor out there, he always gives a test that, you guys know what Gavin Hall is out there? No. Okay. It's one of the center buildings on campus out there. One of his tests in his trig class is that he gives the question, determine how tall Gavin Hall is without using a tape measure from the top. Like you're not allowed to get on top of it. So he says, determine how tall it is without essentially touching the building. Does that make sense? Okay. And that's their test. Okay. And he asks them to be, he gives them like a precision. Says you got to be within maybe a meter or maybe within 6 inches or something like that. Does that make sense? And the closer you are to the actual answer, the better your grade is on that test. Okay? So these are things that we could do, we could recreate at some point. Okay? We could measure one of those weird sculptures out there, yes. Okay? Huh?
Hey, they're beautiful.
All right, so I want to do, before class ends here, I want to do one more. So this is slide 13. This one's a little bit more difficult because there's more information. The picture gets cluttered. But if we're conscious and we spend time with our initial picture, this should not be too bad. All right, so Oscar's in the lighthouse. Okay, he observes 2 sailboats due east of the lighthouse. Okay, it says the angles of depression to the 2 sailboats are 33 degrees, 57 degrees. Puberty hits everybody. Just me a little bit later. So find the distance between the 2 sailboats at the top of the lighthouse measures 803 feet from sea level. All right, so kind of visualize what's going on here, right? We've got a cliff. You guys see on top of that cliff looking down at boats. Okay, so there's our water. Boats are in the water, right?
Yep.
Got a cliff, right? There's your cliff. On that cliff, there's a lighthouse, right? Okay. Now, Oscar's in the top of that lighthouse. He's looking down at 2 sailboats that, It says they're due east, and that's just telling us that the lighthouse does not, I'll just draw this picture real small here, that the lighthouse, that sailboat number 1 is not there, and sailboat number 2 is not there, so they're not separate. Does that make sense? On both either sides of the lighthouse, it's telling me that this boat here, I can't do that, this boat here is actually over here with this one. Okay? And that's important for our operations here in a little bit when we're done with this problem, because if they were separate, if the lighthouse was between the two boats, we do something completely different. Okay? So this is just trying to get you to realize that the boats are on the same side of the lighthouse. So in saying that, it doesn't matter if it said east or west or left or right. Okay? They're both on the same side of the lighthouse. Okay? So draw 2 boats down there in the water. I mean, don't put them right next to each other. 'Cause, I mean, they're not. If they're right next to each other, these angles would be pretty close together, wouldn't they? Yeah. Okay. So if they're like 57, 56, then they're probably touching each other, right? So they shouldn't be that close. So there's sailboat number 1. Let's call this sailboat number 2. Okay. Now Oscar is looking at those, right? So when he looks at those, he's got lines of sight, correct? So there's one line of sight. There's a second line of sight.
Kind of like the waterfall.
Yeah.
Question
Say again?
question number 1.
Okay, so now if I look, so just throwing information in here, how tall is the lighthouse, or how far is Oscar off the sea? 803. So this distance here, it's 803. Okay. Now it says the angles of depression. Angles of depression are created from a line of sight, so the green lines, and a horizontal, right? We have to add that horizontal in. Now think about this. Which one of those, the horizontal to S1 or the horizontal to S2, which one of those is going to be 33 degrees?
S2.
Let's draw them in. We got that angle there. That's the S1, right? And we've got that angle there, right? Which one of them is bigger? The blue one, right? So the blue one's got to be how big? 57. And the red one has to be? 33.
Oh my God, I'm doing on the wrong one again.
Okay.
Oh my God.
So that is everything that this question is asking for, right? The question at the end is, what's the distance between the two sailboats? Okay. What I want to do here, and I'm going to erase what I have because I ran out of room, and I'm going to separate these. Okay. So don't erase what you have, but we're going to separate these. Okay. Do you see that there's 2 right triangles here? Okay. So when we separate them, you have one. Well, let's do this first. If this red angle is 33, what's this angle? 33. They're alternate interior, right? Is this one 57? Okay. So now I'm going to separate them. So come up here real quick and draw a small version of that. S1, S2. Okay? So, if this point, so if Oscar was up here, this is the base, and this is S1, we said that this was 33 degrees, right? This was 803, right? Do you have the ability to find, let's just call that distance X. Okay? In the other triangle, this is sailboat number 2. Is that 57 degrees? Right angle. Oscar's up here. Is this still 803? Do we have the ability to find Y? Okay, does that make sense to everybody? If I find X, what trig ratio would you use to find X? Tangent. So you'd say tangent of 33 is equal to 803 over X, right? So x is equal to 803 divided by tangent of 33. What would you try to use to find y? Same thing. And what's going to happen? What's the only thing that changes over here in finding y? 57. So when I find y, isn't it going to be 803 divided by tangent of 57? That make sense, everybody? Now here's my question. To find, so x is going to be, so doing blue here, x is going to be that distance right there, right? Y is going to be that red distance. The question asks you to find the distance between S1 and S2. So you're going to subtract those two numbers. Okay? You're going to take whatever that blue number is minus that red number. Okay, yeah, they might be big. Thousands, maybe?
Yeah, the first one.
Okay. All right, so now, when we type this in, and you can do this multiple ways, you can do them separate. I'm going to go 803 divided by tangent 33 minus that 803 divided by tangent 57, right? Okay, did you get a number like that? Okay, I'm sorry, I'm in the wrong mode. Degrees. Did you get that number? Okay. Did anybody get negative 715? If you got negative 715, you just did it in the wrong order, right? But S1, S2 is a distance, correct? So all you got to do is take the absolute value then. Okay. But that's what we're looking for. That's the distance between those two CLOs. Now, here's my question. Does that look like something we've already done? If we go to, let's see here, this question here. Yesterday we tried to find Z, didn't we? Yeah. Is that, if this is S1 right here and this is S2, did we already do that question? Yes. Okay. So what I need you guys to understand is the questions that we do in these story problems, you've already done them all. But you never had a story with them. Does that make sense? Now the story is going to create the picture, and then we pick the ball up from there and continue to work with the triangles like we've done in the worksheets and other assignments. Okay? So it's really nothing new other than reading, comprehending, putting things in the picture correctly, and then using our geometry from that. Okay? Questions on that? No. All right. That turns out to be, that concept of reading story problems, guys, is pervasive through the rest of trig, calculus, pre-calculus, physics, chemistry. You have to be able to read and convert that into information, okay? That is useful to you. I'm going to send you an email that has your homework in it tonight. Yes.